I was in 12 years old. But I also exposed them to
You know what I mean? It seems like
I'm loving the fact that the girls on this thing.
Okay. All right, so what I'm going to do for a second here is I'm going to try to show you how the Windows software works for the data recovery environment for a deep spar. Now, the reason that this is important is this. So on the Atola, I showed you how we could pop over to the original. So on the Atola, I showed you how we could come over here and that we could go to file recovery and that we could actually look at the tree and then recover files. So we can, on the Atola, image what we need, which in this case, it's not very specific. You have to image everything pretty much. And then you have to come over to your target disk, take the tree, and extract what you want. Okay? So this is a combination now. We've gone from, remember your drive only knows LBA blocks. It doesn't know clusters. It doesn't know anything about your file system. It doesn't know anything. This is where we're leaving just physical. Can you wait?
Yeah, broken bit is in the machine or on the cable?
It's out of the back of the device. The cable gets pushed in, and so there's a pin that's not coming out into the power supply.
I can get it from cable.
No, it's not the cable. It's the pin coming out of the back of the machine, which I may either have to open or do something. But
All right, I'll wait a minute.
But I'll try to fix it in a little bit. All right, so the logical content. So we're crossing over from physical to logical, because so far up till now, and at least through other than DRE that was DE, which is PC3000's version of their logical recovery software. That's been around for a while. It's been around for a decade or more. That was one of the only versions of the software where you could do a logical recovery mixed with physical recovery. So what I'm going to show you is how the deep spar deals with something like this, where you can actually then look at your tree and extract your tree. So I'm going to come over to a deep spar, and I'm going to show you initially what happens. Now there's two pieces of software for the deep spar. There's one that's in DOS, and there's another one that's in Windows. And they sell something called the network module. The network module connects you from the deep spar over network to the data recovery environment on a Windows machine. And then Windows will then communicate with the deep spar and then dump the stuff on your local machine. It's a little cumbersome. Once you got it set up in your lab, it's pretty good. I don't have a network set up here. I don't have cabling and all the other stuff. So the software works locally if you bring the drive to it. So it'll work both locally and over the network. The only difference between using the network module and doing it locally is one thing: file systems. If you want to do HFS or EXT, you should have the network module. If you only want to do NTFS, then you don't need to have it. And the reason is HFS and EXT cannot be processed locally on the deep spar itself because it doesn't have enough memory. So it must be processed on the Windows side. Do you guys understand what I mean by this? So there's not enough memory to build the tree for EXT and HFS. But there is enough memory because NTFS only has 2 sectors for every entry. So you can specifically recover stuff that is only NTFS directly on the deep spar without doing anything else. But if you want to do HFS, you use the data recovery environment, you connect to the deep spar, and then you control the exact same thing but in the data recovery environment. So I'm going to show you the basics of how this works, because it's a little cumbersome because it's not very pretty. They're terrible at writing code that is a user interface. That's the best way I can say it. And that's kind of putting it kindly. You seen visual? Anybody ever made a Visual Basic project before? If you've ever tried to make a Visual Basic project, you start with this big old blank sheet and you say, I want to make a project, and then like a little box opens up and you create one, and then you have a blank slate you have to draw from. And that's what it looks like. It still looks like the blank slate. All you have is a button that says make a project. And it doesn't even work correctly. It's pretty bad, but it does function. You can do what you want to do. So I'm going to show you how that works. So let's say I start with a drive. I'm going to start the deep spar. I'm going to start the deep spar. So I'm going to do my normal thing that I would normally do. As soon as a drive comes in, guy says I got to have payroll tomorrow, or I need pictures for this case or something. F11, power it on. Hope for the best. If you get lucky enough, you're going to get drive seat complete, drive ready. Then you hit R, and it rescans. So we all went through some of that yesterday. So once you get that far, now the next thing is that I'm going to jump straight into the drive. So I'm going to say OK, and now, let me reset this so that it's not, I've been using it for too many examples. So when we were here and we said OK, we would come into a blank drive. These two drives are married together. The source drive and the destination drive keep track of each other. The destination drive keeps track of the serial number of the drive that the image is on the destination drive. And at the end of the drive, so if you have 100 gigs and you're writing to a 200 gig drive, right past 100 gigs, it makes a configuration file. It's a binary configuration file. It keeps track of the logging, it keeps track of what happened to the sectors, it keeps track of the source drive, and they're married together. So you can unplug the two drives and put them on the shelf and come back to them a year later, plug it in, and it will still know where it was. Every setting you change is saved in the configuration file, so they go together. Everybody understand? So all the configuration information is in that destination drive. Now, so a jump into it has never seen this drive before. We're starting fresh, as if it had never been there. So what I want to do, if I was trying to be really quick, what I'd really want to do is I would want to do just the metadata, right? I would only want to do NTFS structures. And the reason I say this is so if I do NTFS, those are the things that build the tree. But that's not the data. That's just the tree. There's no data. Everybody understand what I mean? So don't get confused by it when it happens, because the representation of the tree, people confuse all the time with the fact that the sectors are there. They're not there. So what I'm going to do is I'm going to start with data. So I'm going to select an imaging area. When I do this, it's got to read the MBR, the GPT structure, and the sectors that are associated with the partition. So watch what happens. I start it. It makes this configuration file. That's the configuration file, and writes this map. Then it starts, and you see it didn't read everything. It only read the beginning of the drive. So the first sector has the partition table. These sectors are read because those would be the beginning of a GPT structure, and there is none. And then here is sector 63. That's the beginning of NTFS in the partition for this drive. That's what that said. You guys understand what I mean? When we did this, like for instance, if I just had that one sector and I go to the home sector and I see that first sector, we use keys just like you do in Word to move around. If you hit end, you go to the bottom of the drive. You hit home, you go to the top of the drive. You can use the arrows to move around. You hit F3 to view. So I can view a sector. Now I haven't copied this one. I've only copied these green ones, right? So the green one looks like it's blank, right? But you can't tell because this was a drive that was formatted but not bootable. So if you hit F3, then you scroll to the bottom. You always have to do this. Hit F3, scroll to the bottom. That way you can see the beginning of it if you're looking for something. So how many partitions do I have? One. I have one partition. What kind of partition is it?
NTFS.
NTFS. 07. NTFS. Right? So you can tell, and if you don't know what that is, the number that is associated with that's stored there. Yeah, 7 is NTFS. But there's this. I need to find a good one, but I just kind of always do like a search, and so. Let's just see if I can tell you. Oh my God, no wonder my stuff was not working right when I was doing searches. Yahoo was the default. Oh my God. Oh, I got to get out of that.
Who else needs the thumb drive?
Yeah.
Great. Nice.
Let's see if I can tell you, if I can find this list.
It does on my Mac. It might freak out on PC. Yeah.
So when you're going to format, when you go to format a drive, and you remember we used to be able to do this in F-disk, you would actually go and you would choose one of these. There was a list, and I know this is kind of ugly so you can't see it right away to see what this list was, but there is a list for your partition IDs, and the content that was stored there is the type of partition structure. So 7 is this. Now it just showed up as a list before. It used to be a 2-column list. 0, 0, 0, 1, 0, 2, 0, 3. Huh?
Is that in our books or?
It's what? No. No, this has always been the standard F-disk. If you actually go back and you did,
Partition type, okay.
yeah, it's your push, like whenever you would do this, and you would select one, this is the graphical version of what you're selecting, it would have just said, what it actually is stamping there is the number. And we used to have to do it by hand. It used to show up, it used to show up as a 2-column list. It used to just show up as a 2 or 3 column list, and it would have the numbers. I don't even see a picture, like nobody even has this.
It's been purged from the internet.
Yeah, maybe it has. Everybody forgot what partition types were. But there used to be a list, and it would just tell you the types. It would tell you each partition type and the number. And it would be, so 81, 82 is Linux swap disk. You would remember if you were doing F-disk, because it was showed up in a DOS list before, and you would actually see it in a list like that. It would just be a list, and I'll find one somewhere. I really need to find one. But it was just a 2-column list that had what each partition type was and what that number was, and that's what it would do. So that's what we're looking at in 07. As you can see from Wikipedia, 07 is NTFS. Okay? Alrighty. So back to this. So I glance at this all the time just to see what it looks like and see where the content is. And the layout of this is actually done in some other stuff. I don't remember exactly, but there's 32 bits that will show the beginning location of the sector. It's 2 things. There's a starting location and the length of the clusters. Yep.
So, quick question for you. Like at the end, in 55AA,
yep.
If you want to, the system to ignore the file system.
Yep.
So do you just, how do you remove it? How do you remove that?
I'll show you.
Okay.
Give me 3 minutes. That's the next thing that's coming. Okay? Because it's already a setting in the device. So, because right now Windows would try to mount that, and there's no data, right?
Yeah.
So I'll show you how to do that. So at this point, all I've done is I said I would like to do the NTFS volume. I'm doing NTFS. Now, there are 3 options here that are not, besides the default one, there's 3 options. Now, just trust me when I tell you this, because I've reported it. I don't know if it's been fixed. I don't really care if it's been fixed, because I don't use the second one. The second one that says specify files by MFT mask, that would be like I want all *.doc files. And it will actually search through the MFT entries and find those and then recover those files. But the problem is, if you have tick marks in your file name, it doesn't work. So you won't get them all. For some reason, in their parsing, you know how sometimes when you're writing a program, if you have a comma, or you have a tick mark, or you have a slash mark, that you didn't filter those out, I guess they didn't filter those out. So it does not correctly do them with tick marks. So I don't use that one. I always use the all, and I build my own tree. So this one right here is all files indexes, directory structures, and bitmap. That's what that is. Okay? The bitmap tells you allocation and unallocation. So I'm not copying the whole drive. I only copy what I want. Okay? The other one is select all partition. So if you have 6 partitions on your drive and they're FAT32, all you can do is select all of them in one partition. So that's the only other time you would select that, which in this case is the whole drive. If I selected this, unless I had 3 partitions, it's the whole drive. Right? Everybody understand what I mean? So I'm going to do this one. I'm going to do all files, indexes, and bitmap. And that will tell me everything I need to know and build my complete tree. So I'm going to select that and hit enter. I always do that. So now you see it doing all the file records. So it's reading all the MFT entries. Parse those, that's the bitmap, and read the bitmap, and then it's selecting those. So there's 74 gigs of data on this 100 gig drive.
And you're saying this only works in this DOS version for NTFS?
The DRE environment also, which is the Windows environment, I could have done this through a network cable with the Windows version. It will not do it for Mac OS, and it will not do it for EXT here on the screen like I'm showing you now.
What about FAT?
FAT, it does not parse any of the catalog for FAT in this version. It does it on the Windows side.
Right. Now, couldn't you run the Deep Spark hardware in a regular computer that runs Windows?
No, you cannot do that. The way you were looking at this machine now is the way it shall always run. If the Deep Spark, your Deep Spark has to run in DOS. It's running in Caldera DOS. You cannot run it in a virtual machine. You cannot run it in, nor should you. If the Deep Spark detects anything else plugged into the machine, it'll erase it. It becomes a part of the system, and so there is an option called configuration drive. So if your Windows hard drive is plugged into it and you think you're making a dual boot system, that's your configuration drive, and it will start writing the data to it. Now, they did that on purpose because of my request for forensics. Right now, it wrote the config file to the same drive. It's at the end of the same drive. So if you have a 4 terabyte drive, how do you, in the day they sold a 4 terabyte drive only, how do you get another 4 terabyte drive that's bigger? You can't. It's not possible. So, but I don't want to write my data to the same drive either. So I have an option at the beginning called a config drive. See it down in the bottom? So if I plug another hard drive into the system, the configuration data will not be written to the same drive. It'll be written to a different drive. You select it by number. So there's a number, and it'll show you which number, and you type in the number of the drive on the left. The thing is, then all 3 drives are married together. Your destination, your configuration, and your source. They all go together. So this is a good way to separate out forensic data so that you could save it separately rather than modifying the original drive. Does that make sense? So you could have 2 drives exactly the same size and image to them if you have a configuration drive.
So if I purchase Deep Spark, I have to get another computer.
Here's the amazing thing. All the stuff you're looking at in front of you is cheap. The Deep Spark is the expensive part. You don't need more than $70 in motherboard stuff because all you need is a power supply. The motherboards that I found the best are old cheap motherboards that have NVIDIA interfaces on them. Remember, NVIDIA used to make a chipset, not just a video card. They made a chipset. They stopped making it because they got sued. So Intel sued them, and they stopped making but their chipset was super fast. It's the fastest chipset I'd ever used. So some of these older motherboards that are on the table have these NVIDIA chipsets in them. So the list of ones I have over here, it's hard to get them now, but you can shop them around. And they use a 2.7 gigahertz Cepron processor. I'm using an AMD processor. So I've got $30 in the processor, $25 in a motherboard, and 1 gig of RAM is all you really need. So 2 gigs is about the minimum you can do. So we're at about $70 and a power supply. The power supply is probably the most expensive. If you want a good power supply, you pay for it by weight, right? If you don't know that about power supplies, if you walk in and you pick up a power supply and it's $25 and it's light, that's a piece of crap. If you pick up a power supply and you go, oh my God, this is heavy, that's the good one. And that one's also going to cost you $200 or $50. So I'm using a $50, $70 one here. So that's my most expensive part in all the components.
And some brands still use even better parts than power supplies. I mean,
Yeah.
you can't go wrong with something like Corsair.
Right, I agree.
Big.
But then you're paying for it.
Yeah, right.
I splurged on the power supply. I figured that would be the
Power
one thing
supply
I
is
don't.
important.
Right. The power supply is worth every penny.
Yeah.
Yeah.
If there's anything you're going to buy a good brand name. I use Thermaltake and whatever is a good brand. But that's, so you don't need a whole machine. All you need is a $50, $100 motherboard and that's it. If you're really stretching it, because nothing else matters. Only I/O speed matters. It's not processor speed. Processor has nothing to do with it. You will exceed the processor. This stuff was written in DOS. There's no multitasking. There's no threaded. There's no nothing. All right. Okay. Answer your question? Good. Okay. All right. So now, all I have copied, because I selected this, I said partition, I said this, reload, blah, blah, blah. It did the whole MFT table, read the whole thing. It's already done. And now it knows I have 74 gigs, right? It did not read anything else except for MFT entries, directory structures, MFT entries. Everybody good? Metadata, nothing else. There is no data on my drive, just metadata. No tree, no nothing, just the metadata itself that will make the tree. Everybody understand? So when you see this in Windows now, don't be freaked out and think I have the data. So I have just that copied. Now, before I disconnect the drive, I have an MBR. If I have this plugged into Windows, Windows will try to mount it and look at the files and update tables. I don't have them on the drive. They're not there. I didn't make a security descriptor. There's 16 possible tables. I only made 2 tables and a volume ID. Everybody understand? They don't have the rest of them. So you don't want Windows to see the partition and mount it. So you come down here and you say deactivate MBR. Right there. That is the answer to your question. That's what it did. If you make it anything but 55AA, then Windows will not see it. Everybody understand? Wilson? What? Okay. Everybody good? All right. Next. So the only other thing I need to make sure I say to you is you cannot have an HPA on the drive when you do this. Remember, you have 100 gigs. You have 100 gigs, and that 100 gigs then overlaps where the config file is. So if you have an HPA, it stops it at 100 gigs, and the config file is outside the 100 gigs. Windows can't see it. Do you understand my point? This would be the one time I would say you do not need an HPA so you can see the config file. Is everybody clear? Okay, so I'm going to get rid of my HPA. I'm resetting my HPA just to make sure it's gone. It may not, I may have never had one, but I'm just setting it to its maximum, okay? I can actually look at that and tell. There is a way for me to tell. It's quicker for me to hit the button than look. Because if I have to look, I have to do this. I have to go, I'll explain all these other things later, but I have to go all the way down here and look at my enable commands and look for my HPA. Okay? All right. That's it. That's all I need right now. Now, if I was on the network connection, I could just do this without unplugging or turning off the drive. But I'm not, so I'm going to do it in DOS and Windows, and it's going to be exactly the same thing, just no network cable. Okay? Everybody happy? So, if it was a Mac, I need to do it on. Okay, turn the machine off. I'm taking the destination drive, the drive I wrote to, not the source drive. I'm taking the destination drive off. I'm going to go over to my Windows machine. Now, I'm going to show you when it starts up. Now, I got rid of the HPA, so the full size of the drive should be here. It's a 320 gig drive. If it's less than 320 gigs, my HPA didn't take, or something happened, right? The next thing is, it should not mount and show it in Windows, but it should show up in my device manager because all devices will, okay? So I'm going to plug it in. Now, why do I have a red circle?
55AA?
Right, I have no 55AA. I have 55BB. So it does not think it's initialized. But I can still access it. I can still use it. I can do everything I want. There actually is a partition here, right? Because we have a partition table, and the partition table says there's a partition, and I copied the metadata. So I would have 100 gigs. It would be right here. And if I put 55BB there, it would show it to you. But I also have corruption, basically because there's no data, right? Now that's all I need to happen so that I can have access to it through DRE. If I was on the network cable, I don't even have to do this. So I'm going to close this now. Now, DeepSpar has this recovery environment, and it looks horrible. But I'm going to point it out to you, okay? This looks like a bad Visual Basic. Someday they'll make it look awesome. But now here's the thing. They make you make a project file for no reason. Right, it's terrible.
Yeah, and then if you go back, it's not like you can open the project.
Right, or use it, or anything.
So ridiculous.
Right, it is. It's terrible. So here's the thing. Watch this. I have to make a project file. So I'm going to give it a name. All it does is make a directory. That's all it does. So I'm going to give it a name. And this name is DC 2015. Okay? Bam. I made a project directory. You can see it right here. See it? DeepSpar, data, DC 2015. That's what it made right there. And then a recovered folder. All right, now I need to select the drive. If I was on a network, what would happen is, it's exactly the same. There's a drive down at the bottom. You see that 300 gig drive? That's what I expect that I'm going to talk to. If I was on the network, it would be exactly the same thing. It just would have a project ID from the DeepSpar. It'll say DeepSpar, a serial number, and excuse me. That was my trying to stop from sneezing. So it'll be a DeepSpar, and it'll be on the list. The network connections will be on the list. They'll just show up there. It'll poll it on its own. Okay? Don't ask me what port it is because I'm on the inside of the firewall, not on the outside. All right, so here's the 300 gig. All right, now here's where it looks really crappy. Now, so you see the sectors that we copied? It shows you in the map down there in the bottom. So we actually have the sectors that we copied. We can still go and look at them. I can click on here. I can see it in hex again. So if you scroll down, you'd actually see 55BB. See it? So that's what's on the drive. Now, all right, so we're going back. Now here's the project directory. Wait a minute, here's my... Yeah, I was just trying to see if they changed anything in the update. So
They said it's super awesome now and faster. And
yeah, whatever.
I don't know about that.
Yeah.
The other thing that drives me crazy is where it created that subfolder.
Yeah, it's
There's no
deep.
way to set a preference to always back it up to a different, a different disk.
Drive or
yeah,
anything.
so I have to set that every single time,
Right.
which drives me bananas. I don't know why that.
I know. I understand the problem. I'm sorry. I do understand the problem that you have to physically then go and select it and then change where it's going to go and then do it because you're saving it to your local C drive every time, which is usually a small disk and not the place we're actually writing it to.
Yeah.
I don't have an easy answer for you because they're not good interface programmers. I think like Yurk sitting in the back corner somewhere hacking away at it, like he's
in the back.
Yes, right.
Yeah, I mean, he's a nice guy.
He is. They're smart and it works, but
I think I'm going to send him an email about that.
Yeah, I think, yeah. And when you do, will you also ask them, because I've asked them and they haven't done it, the check boxes we're about to check, they don't save. Are they saving them in the newest version? Did you do it yet?
No, they're not.
Right. So here's the thing. See this partition? This partition is the 93 gigs from the drive I just copied, right? This is just the metadata. This is the partition structure. Now, and they should just kind of build this tree automatically. I don't know why they don't. So you right-click on it. You say, scan your file system. Bam. Say, do you want deleted files? Yes, I'll take them. Now, the deleted files are files. These are not carved files. The MFT entries have a flag that says you deleted me, but I'm not gone. Do you want me or not? So that's what that means. So I'm going to leave those and say, OK. Now, it goes over there, and it parses all the MFT entries. So it's eating away at them. You see a little thermometer bar going there across the thing. Builds the records. Then it'll come up and There'll be a tree, path too long on some of those. That's the other thing I don't like about how far deep down they go in their list, but you know, it'll work. So now you see it says found. And of course, they should have done this too, but no, they don't just give you a tree. You have to click on it. Now remember, dot is current directory. Remember in DOS and double DOS and things, dot is current directory. Well, you have to select current directory. Woo, look at that. There's my stuff. I don't know why it didn't just select, but you've got to go, you've got to manually walk this whole thing. Now, here's the thing. You say, hey, I don't want the whole hard drive. What I want is, okay, we've got a user folder, and it didn't even expand, you know, from that standpoint. So you got user folders. You have documents and settings. Oh, look, there's a guy. The client's name is Francisco Pelamonte. Now, Francisco Pelamonte has his folder, which we'd always want. That's always what everybody wants. And you could try to do the My Documents folder or something else like that, but most of the time there's going to be a PST file sitting in an app data directory, and you're going to need that. But, of course, yeah, we want some polygraph secrets. In the pictures, you'll see there's My Hot Girlfriend. Everybody wants to see the My Hot Girlfriend pictures every time. So that always comes up. So we're going to take Francisco's directory. So we're going to check it, okay? So we checked Francisco's. And trust me, don't just go checking individual folders everywhere, because you have to write them down. The checkboxes are not saved. They're only saved to image them. Their project file is 0 bytes. It does not save the checkboxes. Don't look at me like that. You total people. We do the same thing. We're like, what? So it's easier if you select less directories, so you're not confused later on when you try to recover the files. So you do it from the root, or whatever you can do. So you do the directory that you need. The other thing is, you know, I usually explore whatever else is down here in the disk to see if they arbitrarily wrote something to the drive. And there's some more hot girlfriend pictures, so we need those.
Absolutely.
Yep. So, because, you know, you never know what's in those directories. And then, oh, it's also helpful if you go look at the recycle bin, because occasionally, you know, there's hot girlfriend pictures in recycle bin, but not today. Anyway, so I've selected those folders. Now, that is actually going to be the majority of this drive, because they are professional pictures, they are high-end pictures, and they are large pictures, and there's a lot of them. So out of that 74 gigs, it's like 50-something gigs of it. So I'm only going to skip like 20 gigs of this drive and blank space. It actually copies clusters, not sectors. So clusters, and you really want it to do that, but clusters and the cluster boundaries will have slack space in the cluster. So it'll copy the whole cluster. All right, so I checked those. All right, everybody good with what I've done so far? And then you select for imaging. And so then it will turn around and it will select all the items that you have checked. Okay? So now it's selecting those items, writing this to the image file, to the configuration file on the disk while it's done. So it's selecting all the fragments. It's converting them all to LBA blocks, so they're all in order. So it's not thrashing around. It's actually going to do them all in order from 0 to the beginning of the disk to the end of the disk, and it's highlighted them all. Okay? Now you could save. You can save the file. You could hit save, save, save. Woo! Look at that, save. Now let me show you what it saved. See that file? That's the file. 0 bytes. It saved nothing. It's just a directory structure. It's nothing else. It didn't save anything. So you can't open this. You can't do anything with it. There's nothing to do. So you just have to remember, that's what I selected. Everybody good? All right. You're actually done with this. You don't need to do anything else. Once you've selected the tree and the items you want, you can just close the project. The other thing is, too, you know how you go to eject a disk? Technically, I'm just going to point out, you don't really have to eject this disk because it's not mounted. Right? Windows doesn't have access to any of the tables. So it's not going to corrupt anything if you just unplug it and turn it off. Okay? So that's all I'm going to do. I'm now done. I've already told it the config and what I want it to do. Now I'm going to go back to the DeepSpar. I'm just plugging it right back into the DeepSpar and powering the DeepSpar on. If I was on the network, it would just do it on the fly. It would just do it on the fly, and it would just drop the files to my directory. So by moving back and forth, and trust me, I can't fit one more box in my car right now when I'm driving up here. So I can't build out a whole network as well.
Bigger truck.
Yet, huh?
Bigger truck.
Well, what I'm going to have to do is change the class is what I'm going to have to do. I'm going to have to create just a TOLA class, a Deep Spark class, and then just have network stuff, and we're not going to do all this other rebuild stuff, so the box will then change to a networking box. That's my future plan. There will be 2 classes. It'll be Deep Spark, and then a TOLA, and then 3 classes altogether, because I won't teach those together. I'll teach them separately. All right, so... So now we go back to where we were. That's the advantage of doing the network stuff, is you don't have to do this part again. Enter. Now all that stuff has been selected. So now what you do is you hit Control S, and I'm just going to start from the beginning. And now you see that box that says Image Selected Area Only. That's the part that is specific to this job now. So when I hit Enter, it's just going to start imaging the content that is all the hot pictures, the My Directory, which is, like I said, the majority of this drive. So the point it will be is it will skip a lot of things it doesn't need. And you'll see it when it does chunks. And you'll now see there's check boxes for the files I've selected. So the things that I've selected now have check boxes for those sectors in the process. So this will go fairly quick, but it won't go instantaneous because we're copying 50-something gigs. So it's still going to take half an hour or so for this to happen. So it's not really a thrilling event to watch for 30 minutes. So I'm going to let that go for 30 minutes, and then when we're coming back after it's done, I'll show you. But it saves a lot of time, especially on a huge drive. If it's a 2 terabyte drive and you're only copying 50 gigs off of it, it knows where the 50 gigs is. So you don't have to do anything, and it's very safe because you're only touching the sectors you have to touch on the source drive, and it's cloning them to the destination drive. So when I'm done, I'll just take the destination drive, come over here, and I can just click on those pictures and extract them. But I must remember where I put the checkboxes. If I go down to the Windows System folder, and I try to select a file and copy it back from the Windows System folder, it's just blank space or trash or whatever's on the drive. Anything left that I didn't erase or overwrite, it's just going to be that junk. So I can only get the files that I want. You must restrict yourself purposely to that. And if anything should be updated, the checkboxes for what we selected for the project should be updated so that we know, and there should be a warning if you try to get a file from another directory. Now, here's the other thing is, the DRE environment, yes, you can go back to it and you can select the files and extract them, but I personally don't do it that way. I prefer to use RStudios to do that. So you don't need to use the DeepSpark software again to do that. I can actually go to RStudios and do, maybe a better job from that standpoint, but it's really just the files that exist, so they should be equal. Okay? Everybody good with this concept? So this is now logical and physical combined. And it certainly is a lot easier to click that on the Atola, but the Atola doesn't image it by itself. You can't do a specific folder selection. Do you understand? Because you can only image the drive and then go to the destination drive, select the tree, build the tree, and extract those files. It doesn't tell you. That's why I said on the Atola, if I had a wish list of what I wanted to do, that's the wish list, is when I'm over here and I'm on my source drive, that I come hit this tree, and instead of you guys popping up that box that says don't touch this drive, I would rather have the tree as it's done, build and copy to the other drive, show me the tree, I check a box, and then say recover that, and then it automatically clone it to the other one without hesitation. I don't need a box to tell me the safe way, just do it the safe way. Understand my point? That's the piece I'm missing. That's the one thing. At least there's a box that warns you now. He only added that in 4.3.
Right.
So that wasn't there before.
You already made that request.
I did. I made this request. I've already made this request for 2 years. Let's get it done. Okay.
Aren't you happy you came?
Hey.
Well, we had Derek from Kingston and all those guys in the strategy saying they needed EO1, they needed EO1. So I think that.
I agree. I'm not going to disagree with that. I think EO1 is very, very important. EO1 is in-case file formats, and if you're going to, the nice thing is it does compression, it does some other things, so you can do, and I haven't played a lot with it, but I agree, it's a very valuable asset because I don't always want to work with a clone.
Right.
I want to work with EO1s myself, or I want to work with a DD.
Sure.
I'd prefer to do that from a forensic standpoint, which if you're calling it forensics, it should do that. So I agree. I do agree that that's a good movement. But now you need to make that right to EO1 with that tree.
Okay. Yeah. Well, it was like 170 improvements, and EO1 was just one of them. So that's
But
pretty
that
amazing.
one wasn't.
I know, but that.
And then the next version, that's got to be one of the top 10.
Yeah, exactly.
Because this is surgical recovery, and it can be done instantaneous,
Right.
safely.
Right.
Yeah.
And if I go back and tell Dimitri, Data Compass does it. Go back and tell him that. Salvation Data can do it, and you can't.
Give them credit. Right.
Why can't we?
All right. All right, I don't want to get into it, but I'm not going to pick on just the one. Like you know what I mean. But that's the point. It's very valuable. I'm just going to say it's really awesome that it works, but still, that's the case. So we're going to come back to this in 30 minutes, or whatever. Blah blah blah. All this logging and all this stuff is supposed to be stored. That's the one thing I have an argument with the DeepSpar on that side too. As I already told you, if you use DRE and you use that software over Windows, if you connect to multiple systems, and this is really an advantage. If you think about it in these terms, if you want to control a DeepSpar remotely, you cannot do it in its current state without adding something or using DRE over the network. So if you're at home and you want to check the status of your DeepSpar, you have two options you can do. One, buy a network keyboard management system. You know what I'm talking about? The KVMs that are networkable. Then you can change out your keyboard and your monitor and plug those two into that management system, and then you could control DOS remotely. A lot of people are forgetting how to do DOS these days and stuff, but you can do it. The second thing would be just have all your Windows system have remote software on them and use DRE to connect to them. Now that's where your problem comes in. You can connect to them and take over the DeepSpar. But when you do that, whatever logging is running, you then take possession of the logging, and your logging doesn't get saved to that logging. So that logging is in multiple places. So if you connect to multiple machines, now that logging is over multiple machines. Understand my point? And you lose it.
You don't get the logging on most of them.
It doesn't save it in one location. Only saves it in the location with which you are controlling it from. So, keep that in mind as you're doing it. So if you just have one remote management system or one bank or something like that, then you can do that. So those are your two options. So I do that. I mean, I'll log in remotely to my DeepSpars from the road by logging into the Windows machine, finding it on the network, connect to it, and then I can see the job that's going on or modify the job or change it. And it's exactly the same as what I'm doing there. You're just doing it through a terminal, basically. It's really a WISE terminal interface. That's really what it looks like. Now, our studios has a technician license, which they also have. I can connect to my DeepSpar in the technician license. So in the technician license, it shows up as a drive in the tree, and it says DDI image. So it's exactly the same as our studios is. So when you're looking at our studio, I do not have the technician license on this drive. All it does is it automatically pulls remote connections. So it's on a menu, actually. It'll be on the menu, and right here on this menu, there'll be an option right here. Instead of connect to remote, there'll be another one that says refresh DDI. And right underneath it. And then when you do that, this list shows up. And if there's a DDI on the network, it'll say it right here. DDI, blah, 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 serial number. And then when you connect to it, then you have the same controls, but now you're actually doing your recovery inside of our studio with better software than DRE. Okay? They have a license agreement and stuff that goes back more.
DeepSpar will do with the Tola too? Or
No.
DeepSpar?
For some reason, Dimitri actually, because Dimitri knows about this, he somehow decided not to go that route. And only, I got to believe there's a lot of complexity there. See, here's the difference too. DRE on a DeepSpar is not relying on DRE to survive its functionality. So in other words, the machine is running on its own, and if the connection is lost over the network, it doesn't affect its ability to run. the DeepSpar will continue to do its job because it is a terminal interface to it. Okay, understand? Unlike the Atolla is dependent upon the network connection and the Windows machine. If you lose your network connection, it does stop functioning. It is a slave to the Windows machine. Now, inside the DeepSpar, there's a Linux box. Inside the DeepSpar, Linux is running, and there's... I'm sorry. Thank you. Inside the Atolla, there is a Linux box running, and it has its own interface, its own storage, its own stuff. And so, but it is dependent on the network connection to your machine, and that's where the action takes place. So it is a control mechanism, but the Windows software has to run on the Atolla side to do anything. Now they have other boxes. They have another touchscreen box where you could run things automatically.
We used to.
Yeah, you stopped making it Bandora or something?
Just Bandora, yeah, we used to.
Yeah, because it was a very dumb device as a whole, and it had a touchscreen on it, and you could say go. Yeah. And then you could touch the boxes and say copy, and it's a cloning machine. But it was independent, and it ran on its own. But, or really, it was just another Windows interface, a CE or something like that, sitting on top of it, right? Or
I'm not sure.
Something. Okay. It was just built into the tool, kind of like Celebrate does. But that's how that works as a whole. So you are dependent on this. So you cannot break the connection from your Atolla while you're imaging, and it survived the process. But you can on the DeepSpar because... And that's the other thing is the DeepSpar's interface for that, being over a terminal interface, is also slower. It is really like a remote control. It is a slower interface. But it will drop the files locally to your machine. When you say do something, when it's processing it, it kind of covers it up. It's just covering it up with a, I would have said pretty GUI, but the DOS screen's actually prettier than their GUI. Okay? Everybody good? All right. Everybody understand so far? So you kind of get used to thinking about how those things are laid out like that, though, and their processes. So, all right. So let's get into talking about the content that we're examining while these things are going on. So the MBR. The MBR, you have 4 primary partitions, or you can have 3 primary partitions and 1 extended partition that then can extend other partitions. Extended partitions are just partitions wrapped in other partitions, but they're wrapped inside that partition. So they start with one, point to the one, has a chain, then they're not kept in the table. Only the first one's kept in the table. My understanding is you supposedly, I've known people that have been able to make up to 71 or 72 partitions inside of extended partitions. They just keep wrapping inside of each other. There's no real limit as far as I know, but there's a limit to the primary partitions. Most people are only using extended partitions for dual boot systems at this point. So Linux has a dual boot system. It uses 1 primary partition for a boot one. Windows has a primary partition. Then there's an extended partition. Inside the extended partition, there's a swap file, and then there's a user's extended partition. So those are the only ones really today. There's not this big movement like there used to be to start breaking up your partitions into multiple things. But then you have the GUID partition process where you can have 128 partitions. Partitions mostly, the majority of them past 3 at this point, are usually because you have a server. Servers need a partition for the OS, for Exchange server, for the user, for the installation directory. There's a list of those things, right? So this is what it looks like. This is the old style. They converted this from CHS to 32-bit storage for a pointer for the beginning and how big it is. So we've been looking at this. You at least know what I'm looking at when I'm talking about this. So now let me kind of give you an idea of the layout of the disk and where this is important, because this is where physical and our logical file systems are going to start playing a part in our MBRs and everything else. So all the way back to Windows, all the way back to DOS 1982. IBM says, I'd like an OS. Microsoft goes and buys CPM. They change CPM and modify it and call it IBM DOS, and they sell DOS to IBM. You're thinking in terms of a hard drive that you're manufacturing back in the early 1980s. So you've seen a picture of it in your book, and this is where things will start to make a bit of a difference. On the first page of that book where we were looking at this drive, orange, head assemblies, all this content, you have to think about how your hardware works in order to talk to it. Now today, programmers don't think much about that. They're like, okay, whatever hard drive's plugged in, we're going to make a request, give me a sector. And that's what they do. Not back then. Back then, you had to know how to talk to your hardware. So when you're looking at this particular drive, look at it like this. And this legacy stuff carries all the way through. We're still dealing with legacy stuff. It still exists today to deal with it. So your hard drive, this is upside down, by the way. If you're looking at your hard drive and you have 3 platters, it's really starting at the bottom and counting up. It's usually 0 at the bottom, then 1, then 2, then 3, then 4, and then 5. So 0 through 5 is 6 heads. Okay? Everybody good? So, if you're looking at this, this is a cylinder. When you say cylinder, when you say CHS, you're talking cylinder, heads, sectors. So a sector is the 512 bytes on the disk. Wherever the track is that goes around, all the tracks that intersect each other all the way through the disk are your cylinder. Everybody understand? So you have a track, cylinders through all of them. So you take a cup and you put it over your track and you push it all the way down. And wherever it touches all the platters, that's your cylinder. That's what it looks like. That's where C comes from. Heads, the number of heads you have, 6 heads. Now later on they started using it as a mathematical calculation because when we got to LBA blocks, it no longer mattered what CHS was. What mattered was the number of LBA blocks that you could say you had. And so they used mathematical calculations to make that happen. In the first book, if you still have your first book in front of you, turn to page 72. Yeah, 72. The very last line in page 72 says LBA blocks equal cylinders, heads per cylinder, heads, sectors, tracks, plus sectors minus 1, which gives you 0. It's the number of sectors minus 1 equals 0. That's the formula for LBA. For logical block addressing is derived from CHS. That's how you could do the mathematical calculations by using remember when we used to actually have to enter into our BIOS how big our hard drive was, how many sectors it was, how many heads it had, and that became a mathematical calculation for how LBA works. But LBA still uses CHS. Now here's the thing. F-disk. You guys remember F-disk? The DOS tool you had to use to format. First you made your partition, then you formatted it. You had 2 steps, right? You had to use F-disk to create a partition. Then you used format to format it whatever you wanted it to be, right? So F-disk, when they're designing F-disk, they have a definition that they say you must follow. All the way through 2008, F-disk had a definition. It said a partition must begin on a cylinder boundary. That's what it says. Still says it in the documentation today. You can go back and have arguments with people about it. It must begin on a cylinder boundary. So what that means is, if you have a track and the track starts here, the segment for all the cylinders that goes all the way through that can only begin on one side of one disk, on one platter, on one track. Not in the middle. Your partition cannot start here. Your partition cannot start here. Your partition must start physically on a platter based on this drive back then, because you had to turn off a head and turn on a head to read the other side of a platter. Do you guys understand what this means? How long do you think that takes in 1982 to turn off a head, turn on a head? If you could put a partition anywhere you wanted, it could be, 4 platters deep. If you searched for a partition, it would take you all day. You had to look at every sector on the disk. So they decided, let's not do that at all. What we decided to do was, it's a lot quicker if we just leave one head on one side of a platter, and your partition must begin on that platter. Then I can move across the top of the platter and I can say, are you a partition? Are you a partition? Are you a partition? Are you a partition? And when I get there and say, I found it. Or move across the partition. So searching for it or going to it. It didn't make any difference. It was always one head on one side. Once it was on, there was no more latency. There was no more time taken. You got straight to the partition because it was on a cylinder boundary. That's a mathematical calculation. You can see it still today. If you use tools that say, would you like me to search for a partition? Are you using Windows, Vista, or later? Have you seen that question? There's been tools that will say that. There'll be some I'll show you, but Test Disk is one of the free ones that does this. But almost all the tools will have, now some of them call it other stuff, excessive partition searching. Right? If your partition could only begin on a cylinder boundary, you didn't have to be excessive ever. You get my point? Because you didn't have to search the other locations. It could only begin here. And so across one top of the platter, there's only going to be 216 possible choices, or whatever, however many choices there are. It's a mathematical equation for the length of the disk. It must begin on cylinder boundaries, so it can only begin on a track. So when they went to LBA blocks and they got rid of CHS, they did a calculation, and from one beginning location to the next beginning location is 8 megs. That's how much you have, 8 megs between one to the next calculation. So when you make a partition, it cannot begin and end all the way through XP until you got to Vista. It still was a definition that said begin on a cylinder boundary. So you cannot arbitrarily make it anywhere. Now Vista got rid of that definition. The only reason that we could not get rid of that definition prior to that, Windows XP came out when? Anybody remember? 2001. Yeah, 2001, right? So we had, before 2001, the primary operating systems were Windows 95, Windows 98, ME, for the 5 people that had it. And then we skip a branch. We come to another branch, which started earlier, Windows NT 351, Windows NT 4, Windows 2000, and XP, right? Now, all of those happened within a 5-year span. All of them. 95 to 2001, 5-year span. People did not upgrade their computers every day. They don't go out and, they didn't go to Best Buy and buy a new computer every day for $400. They bought a computer and they kept it for a long time. So from 95, which you're really talking 96, because some of the things they do by the time they have software, they're not even useful for a year. So here's what happens. Windows NT is a server-based platform, basically. Nobody really used it much for a home-based platform because it had no software and it was a derivative of OS/2. And so it was very difficult to use unless you were using it for a server-based platform or a workstation-based platform, but it had a flat memory model. Windows 2000 is being built off of that. Windows 4 was, part of it was partially stolen from Citrix. They forced them to sell a portion of RDP. You know, RDP was originally developed by Citrix. And Citrix was an OS/2 platform. And when OS/2 was plummeting like a rock, Citrix wanted to license NT to take the place of it. And Microsoft bent them over a barrel and literally got RDP for free. Okay? That's how RDP is in all of our systems now. It was developed by Citrix. But they developed NT 4.0 as a terminal server-based platform. You guys remember NT terminal server? That's where that came from. So, but people weren't using that at home. They were using 95 because you could play games. Then 98 comes out and it was really awesome. And it was all the updated stuff that wasn't in 95. 95 didn't come with 32-bit DMA hard drives. That was OSR2 in 95. So you could only get OSR2 if you were a OEM and a reseller. You guys remember this? It wasn't